Going to be doing lesson 3 today of our virtual learning experience. So to get started, same supplies you've needed every other class. Get a piece of paper, a pencil, and a calculator out. Today we're going to start class just with something a little bit different. I know being at home and having a very different routine than you normally do, you might be feeling a little anxious or just a little stir crazy. So we're going to start today's class session with just a little bit of meditative breathing. There's going to be a figure that expands and shrinks, so we're going to breathe along with it. We're going to do at least 3 good solid breaths just so we can kind of clear our minds and get ready for today's lesson. So we're going to breathe in, breathe out, breathe in, breathe out, breathe in, breathe out. Okay, so, and if you want to pause and rewind that and watch that a few more times to help you get into the mindset, that's great. Hopefully that helps you get a little bit more centered and focused for class today, though. So today what we're going to be focusing on is we're going to continue on with the Pythagorean theorem. That's what we were working with last class. We're going to continue working on that, and we're going to then move into some word problems around it, and then we'll wrap up class with kind of a review of all the stuff we've done so far. Remember, if at any point you're having any questions, make sure you reach out and email me. I've been posting the answer keys to the practice sheets the very next session, so I just posted the answer keys of how to get the answers to the 5 practice problems from last class up on the announcement page for this lesson. So if you want to check that out, go look there. They're all posted on my YouTube page, so if you just click one of those YouTube links, it'll show you all of the videos I've created so far. All right, so we can get started. So let's see if we remember, what is the formula for the Pythagorean theorem? It is a squared plus b squared equals c squared. And a and b represent what? They're the what of the triangle. Yes, a and b are the 2 sides that create the right angle in the right triangle, and they're called the legs. And then what do we call that third side that we represent with c? Don't worry if you spelled it wrong, or you might have spelled it wrong. I have trouble spelling it too, but yes, it's the hypotenuse. So what we've done so far is we've used the Pythagorean theorem where I give you 2 sides and I ask you find the third side. That's the same problem we did at the very end of the class, so I'll just remind you. I'm going to make A 3, I'm going to make 4B, 9 plus 16 equals c squared. 9 plus 16 is 25 equals c squared. So then what do we have to do to both sides to isolate c? We have to take the square root of both sides, giving us the value of c, value of just c, because that cancels out, and then the square root of 25 is 5. Right? And this is what we did kind of over and over again in our practice that we did last lesson. But what we're going to do now is, instead of being given 2 sides and finding the third when you're being told it's the right triangle, what we're going to do instead today is I'm going to give you all 3 sides of the triangle. And then it's going to be up to us to figure out, is this actually a right triangle? So we are not sure if what we're looking at is a right triangle, but we do know what we're looking at is a triangle with 3 sides. So let's look at when we have 6, 8, and 10. Is that going to be a right triangle? Now what we're going to do here is we're going to plug them in to the Pythagorean theorem. Which of those numbers has to be represented by c? Right, it has to be 10. 10 is the hypotenuse. It's the one opposite of the right angle. And now in this situation, there is no right angle, so it's hard to maybe tell in that case. The reason why we know 10 is c is always the biggest value. always, 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 the hypotenuse has to be the longest. If it's a right triangle, the biggest value is our C. All right? So now we're going to go in and test these numbers. 6 squared plus 8 squared equals 10 squared. All right? I want you to tell me, do the math on your own, and tell me yes or no, does the equation that this turns out to be, is that mathematically accurate? Yes or no? All right, now that you've said, let's see if you're right. 6 squared is 36. 8 squared is 64. 10 squared is 100. 36 plus 64 equals 100, and 100 equals 100. So yes, that works, which means yes, this is a right triangle. All right? Now let's try with other numbers. I'm going to use, here's a triangle. Oop. Here we have a triangle, and I'm going to say this side is 7, this side is 9, and this side is 11. And I want to know, is it a right triangle? A squared plus B squared equals C squared. Which of these values is C and why? Good, 11 is C because it's the biggest value. So I'm going to plug each of these in. I'm going to make 7a. So 7 squared plus 9 squared equals 11 squared. Now we're going to pause the video and you're going to tell me, is this mathematically accurate? So we get 49 plus 81 equals 121. And then we're going to test those numbers out. 49 plus 81 is 130, which is not equal to 121. So this is not right. All right. So now I'm going to give you a couple sets of numbers, and I want you to tell me yes, no, for each of the sets. So I'm going to give you 3 different ones here. And we'll give, here we'll put 1, here we'll put 1. All right. So my first set I have for you is 5, 12, and 13. Now, which of those is going to be C? Good. This has to be C. Okay. Now, since C is already at the end, maybe just make it A, B, and C. Okay, that's just a suggestion. The next set of numbers I'm going to give you is 8, 11, and 4. Which of these is C? 11 is going to be C because it's the biggest value. And then the last one I'm going to give you is 9, 12, and 15. Now remember, you have a calculator, so it's okay if you don't know what 13 squared is or 15 squared. You have the calculator to help you. Now, which of these values, 9, 12, or 15, is going to be C? Good. 15 is C. So now we're going to pause this video, and you are going to tell me yes, no, yes, or yes, 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 or no, no, yes, whatever the pattern is for these 3 questions. So this is question 1, this is question 2, and question 3. Okay? So try that out. And the answers, if you did this correctly, are yes for the first one, no for the second one, and yes for the third one. So if you got yes, no, yes, good job. All right, so now we can move on, I think, to the next thing that we're going to be focusing on here, which is using the Pythagorean theorem. Now that we know how to find missing sides using the Pythagorean theorem, and we know how to prove if triangles are right, now we can go into some more applications of the Pythagorean theorem. So we're going to go onto a different page here, and we're going to try some word problems. So my first word problem I have for you guys is a 25-foot ladder is placed up against a building. The bottom of the ladder is 7 feet from the building. All right, So we're going to stop there first. A 25-foot ladder is placed up against a building. The ladder is 7 feet from the building. So what that figure is originally going to start out looking like is we have a wall, we have the ground, and we have the ladder. All right? I'll even make it look kind of like a ladder. Which of these measurements, which of these parts of the figure do we not have a number for? The wall, the ground, or the ladder? Which of those do we not have a measurement for? All right, so we actually do not know how tall the building is. We don't know where it is. We know the ladder is 25 feet. We know it is 7 feet from the building, so we know the ground part is 7 feet. But we don't know how tall the wall is. So let's first try to figure out how tall the wall is before we even go on to the rest of this question. So we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. Since this is where a right angle is, that's our hypotenuse, so 25 is our value for c. So I'm going to make 7a, so 7 squared plus b squared equals 25 squared. 7 squared is 49 plus b squared equals, and then what did you get when you did 25 squared? We get 625. Okay. Now from 625, we're going to subtract 49 on both sides. And then we get b squared equals, and then 625 minus 49 is 576. To find how tall the wall is, what do we have to do as our last step? We have to take the square root of both sides. So taking the square root of both sides, all we're left with on this side is just b. And here we're left with the square root of 576. Square root of 576 actually has a value. And if you were to plug that into your calculator or type into your Google, what is the square root of 576? You would find out that the square root of 576 is a whole number of 24. So now we know the wall is 24 feet tall. So let's continue on to the rest of the problem, starting here at if. If the ladder slips down 4 feet, how many feet will the bottom slide out? So if this is our original picture, we're now going to have to draw a new picture. And then this one, which measurement will not change? Will the wall, ground, or ladder stay exactly the same as it was in the original problem? So the ladder is the only thing that size doesn't change, because you can't actually change the size of the ladder in this situation. So the ladder is going to stay 25 feet. But if it slid down 4 feet, now the wall isn't 24 feet anymore. Now it's how many feet? Good. It's going to be 20 feet. And now what we don't know is how far from the wall to where the ladder is. That's what we're trying to figure out. How long is this? But let's make sure we recognize what the question was asking us. It says, how many feet will the bottom slide out? So if it was originally 7 feet from the ground, we want to figure out how many additional feet. But let's find out the full amount first before we go and subtract. Okay? So we know the hypotenuse is 25. We know one of the legs is 20. And now it's just the process of finding the rest of it. So let's get doing our math. So we get 20. We'll just ignore that. 20 squared plus b squared equals 25 squared. So 20 squared, 20 times 20, we get 400, plus b squared equals, and we already figured out what 25 squared was in the beginning part of this problem. We know that that is 625. We're going to subtract 400 from both sides. And then we get b squared equals 225. And then we're going to take the square root of both sides. Now let's break down 225. Let's remind ourselves how we simplify radicals. So when we see 225, I'm going to do this right over here in this little box. Square root of 225, let's break that down. 225 gets broken down into 5 and 45. 5 is a prime number. 45 isn't. 45 gets broken down into 5, which is prime, and 9, which is not. We're going to continue breaking down 9. 9 gets broken down into 3, which is prime, and another 3, which is prime. So then we can rewrite it as the square root of 5 times 5 times 3 times 3. Everything has a pair that can leave. So 5 leaves the radical, and 3 leaves the radical. There's nothing left inside, so we don't even have to write it. Then we just have to multiply those two numbers, and we get 15. So you fully simplify the square root of 225, you get the value of 15. That means 15 is now how far the ladder is from the building. It's 15 feet. So what is the final answer to our question? Our initial question, let me remind you, is how many feet will the bottom slide out when the ladder slips down 4 feet? Yeah, so we'd have to do 15 minus the original 7, so we should get 8 as our answer. I'm going to have the rest of your practice be on your own, so make sure you go to back on Classroom, click the practice sheet. There's going to be a few problems there for you to practice. To help, make sure you draw a small diagram of the right triangle we're talking about, so it's easier for you to understand what is the hypotenuse and what measurements are actually the legs. So make sure you have a drawing to go with each of those questions. To wrap up this lesson, I'm just going to do a quick reminder of how to simplify radicals, because I know that was, I saw a lot of the same kind of mistakes being made across the board, so I just wanted to clear that up. So we're going to just do quick 3 problems just to show how to simplify radicals, and then you can go over to Classroom, do the example problems, and then you're done with math for today. All right, so the first one I'm going to do is the square root of 48. I'm going to break down that into a tree, and I'm going to pick the factors of 4 and 12, just because when I think 48, those are the first two that come to my mind. Neither of those numbers are prime, so I'm going to continue to break it down. 4 gets broken down into 2 and 2. Both of those are prime. 12 gets broken down into 4 and 3. 3 is prime, so that one stops there, but 4 can get broken down even more into 2 and 2 again. So now I can write down the square root of 48 as 2 times 2 times 2 times 2 times 3. There was 1, 2, 3, 4 2's, and 1 3, and that's what I wrote underneath my radical. Now everything that gets paired up, so being in sets of 2, can leave the radical. So I see a pair of 2 here, that can leave. So then I have 2 radical 2 times 2 times 3. And then I see another set of 2. So then that can leave the radical, being 2 times 2 times radical 3. Is this my final answer? Now, while this is mathematically correct, it's not fully simplified, because what I can do now is I can take these two 2's that are outside of the radical and I can multiply those together to give me 4 radical 3, which is the simplified version of the square root of 48. All right? So now let's see what you do with the square root of 72. All right, so now let's break it down. Square root of 72. 72 gets broken down into 9 and 8. 8 gets broken down into 2 and 4. 2 is prime, 4 is not. 9 gets broken down into 3 and 3. So then we write that out. 2 times 2 times 2 times 3 times 3. And I see a pair of 2's there and a pair of 3's there. So both of those can leave. A 2 leaves, a 3 leaves, and there's still what left inside? Right, just a single 2. So then my final answer becomes 6 radical 2. That is the fully simplified version of the square root of 72. All right, one more. We have the square root of 96. So 96, that is divisible by a bunch of different numbers. Which one comes to mind first for you? A lot of people immediately think of 12 and 8. 12 gets broken down into 3, which is prime, and 4, which is not. 4 gets broken down into 2 and 2. 8 gets broken down into 2 and 4. 2 is prime, 4 is not. All right, and then I'm going to take that and put it under my radical. We have a single 3. And then we have 1, 2, 3, 4, 5 2's. All right. There's a pair of 2's that can leave and a second pair of 2's that can leave, so they both leave. 2 times 2 is outside, and then we're left with 3 times 2 inside, and then that will become, finally, when you multiply everything that can be multiplied together, what is your final answer? Good. Our final answer is going to be 4 radical 6. And that is our final answer for the reduced version of square root of 96. All right, guys, that's the tutorial today. Now I want you to head over to Classroom and try out the problems that are on Classroom for you to see how they go. If you have questions, feel free to send me an email. And thank you so much for all of you that sent me an email or asked me a question about the last Edpuzzle. This is a learning experience for both of us, so there was a couple of glitches. I will try to make sure none of those happen this time, but if there are any mistakes you think I made along the way, please just let me know and I will try to go and fix them as soon as possible.